of our 3 sessions for Open Learning JNCIA Cloud. This is Lawrence, happy to be here with you again. And to be quite honest, I don't have a whole lot to say to start this particular week off other than just some quick reminders that you do have access to the materials for 180 days from the date you requested them. If you haven't requested the materials, access to them yet in Junos Genius, you need to send your Junos Genius username to junos-genius@juniper.net and state in the subject line Open Learning for JNCIA Cloud. So if you haven't done that, make sure you do that because you do want to access the materials. That's how you do all the good learning. And just a reminder that you get 3 chances to take that voucher assessment test. Every time you start, it counts as one. So please, if you start, don't stop. You got to go all the way through. And don't waste those 3 opportunities, right? Because we really want you to earn that voucher and get certified. So that's pretty much all I wanted to start off by saying this morning. At this point, I'll go ahead and turn it over to Gordon, who can start us on today with, looks like SDNWAN solutions. So Gordon, all yours.
Hey, thank you very much, Lawrence. Hey, welcome back, everybody. Thanks for showing the dedication to show up for 3 sessions, right? And so guess what? Today we are going to do the last 3 modules in your JuniperCloud Fundamentals material. Consume the material. Remember, I think this certification is one you can obtain if you just go through the materials, right? So good luck here. We're going to start, as Lawrence said, with the SDNWAN solutions. We know how to spell SDN. We know what it means because we've talked about it for a couple of weeks. So what we're going to look at here is how you can extrapolate the concept of SDN to the WAN world. So we're going to talk about really one product in this module called NorthStar, the NorthStar controller. So let's get going. So, software-defined networking, right? I want to separate the control plane from the forwarding plane, and I want to centralize that control plane on an SDN controller. We talked about it, I guess it was last session, in the cloud data center world. We talked about a software called Contrail that's used to build the overlay network that connects the virtual machines that the customer spins up together, right? And so now we're looking at the WAN, right? So a customer, buys WAN services to connect their remote locations together so they can, perform their business functions, right? And so anytime somebody wants WAN services, there's some provisioning that has to happen, right? A network that needs to be built. And we don't want to do that in a manual process, right? Because of the same issues we had in the data center. That doesn't scale. That's not an automated orchestrated newfangled way of doing things. So I want to be able to do the same things I did in the data center in the WAN space. I want to be able to dynamically orchestrate and automate the provisioning of circuits, connectivity for my WAN customers. The big difference, I guess, is instead of like in a data center, everything being in one physical location, of course, a WAN, the name gives it away. It spans a wide area, right? So it's still a network. There's still devices out there. They all have control planes, and they all forward traffic. And I just want to be able to dynamically program forwarding paths into my WAN in this case, right? And so, the whole goal, automated, orchestrated, control, visibility, shiny, new, cool stuff, right, is what we want. And I want it to, why do I want this? Well, then the quicker I can set these circuits up for my customers, the sooner I can start billing them, right? And we have complete visibility into this, right? And we're agile, hostile, mobile. We have just a dynamic a durable competitive advantage here because we can just literally make changes to our network with the push of a button, right? And Juniper Networks, remember the issue we had, the whole reason software-defined networking came about, right, is I have all these individual components, these devices, in this case, these routers that make up my network, and they all have their own control plane in them. They all have to be managed individually, configured. They all will run protocols, and build their own siloed picture of how traffic should be forwarded across the network without having a big picture view of the network, right? So we'd like this centralized control. Instead of relying on these control planes in each of the individual devices, Remember, the goal of SDN is to separate these control planes from the forwarding plane, right? And then centralize that control plane. And that's the SDN controller. And so it knows all the links, all the nodes, all the tunnels, all the traffic, all the demands flowing across the network. And so it can use that big picture view to optimize forwarding paths and then dynamically program forwarding paths into your WAN, right? Big picture view on that centralized control plane. And with this centralized control plane, again, it knows all the links, all the nodes, all the tunnels, all the demands that are currently utilizing your WAN, and it can perform centralized path computations, right? Instead of an individual node trying to figure out how to forward traffic from point A to point B all the way across your network with only really knowing its links and its tunnels, the traffic it's processing, and not really having a view of what this node is doing, right? With this centralized controller, again, the big thing here is I have a centralized brain that has a big picture view of the entire network, and it can use that pool of information to make better forwarding decisions. And once it computes an optimum forwarding path for the new Denver to Sao Paulo WAN circuit, it can dynamically program that circuit in to the network, and that's the idea. Right, and so Juniper has an SDN controller for the WAN space that can perform this function, and it's called the NorthStar controller. And what the NorthStar controller can do is it can dynamically provision MPLS label switched paths, traditionally into a service provider or a very large enterprise WAN. Okay, and so this is the SDN controller from Juniper Networks for the WAN market. Okay, a couple of different modes that it works in. We're going to focus on the operator mode in this module. And the operator mode of the NorthStar controller can discover your network, all the links, all the nodes, all the tunnels, all the traffic, all the demands, all the routes, right? And it gathers that information and stores it on the controller. And then it can use that information when it comes time to optimize the forwarding paths on your network or create new forwarding paths on your WAN. It has the big picture database of information to compute forwarding paths that are optimum, that meet all of the customer requirements for latency and redundancy. And then it can dynamically provision that MPLS label switch path onto the WAN, right? And that's what it does, right? There is another component of the NorthStar controller called NorthStar Planner. And that since the NorthStar controller has all the information about the links and the nodes and the tunnels and the demands and the traffic that's flowing across your network, it can make a copy of that data. It's called an offline model of your network. And if you have an offline model of your network, you can do incredible things like simulate things. What would happen if we do this? What would happen if this happened? If this link fails? If this node fails? How would the customer traffic be affected? Would we be able to forward all of the customer traffic? Would certain circuits, be properly re-signaled, and while others would fail? How much more demand can we add to the network before we start not meeting our service level agreements for things like delay, right, or high availability? And so it's a really a full-featured, very popular product for customers that are selling MPLS services to their WAN customers, right? And that's the idea. It uses a protocol called the Path Computation Element Protocol. You'll hear it referred to as PCEP, Path Computation Element Protocol. And this is the protocol that's used between the NorthStar controller and the routers that make up your network. This is the protocol that's used to discover label switch paths that are on the network, and also to provision new ones. So this is the communication protocol that's used between the NorthStar controller and the nodes that make up your network. Okay, so this is how we discover and how we provision label switch paths using the NorthStar controller. This is how the SDN controller, our good friend NorthStar, programs the forwarding plane. Path Computation Element Protocol. You'll need to know that, right? Path Computation Element Protocol. It's kind of a three-legged horse, right? And so there's the first part is kind of the discovery component, right? So I need to analyze your network. Again, I need to learn the label switch paths that exist currently in this service provider or large enterprise WAN. I need to learn the links and the nodes and the routes and the tunnels that, I need to know everything about your network. And that's the kind of the analyze component. I discover your topology. I discover how traffic is forwarding across your network. And then again, this is this centralized brain, this centralized bag of knowledge that this SDN controller learns about your network. And then it can analyze that information and optimize forwarding paths. As label switch paths are provisioned across a network over time, not every single label switch path is probably using the optimum forwarding path. It might have been the optimum forwarding path when the label switch path was provisioned, but as demands have grown and your network has changed, I can have these LSPs forward in a better manner, a more efficient manner for me and my customers. And it can use that learned database of information to compute new forwarding paths. As I provision a new label switch path, it has to have this level of redundancy and this level of latency to meet my customers' requirements. With this centralized database of network knowledge, I can then compute a path that meets my customers' requirements, and then I can signal using PSEP, or I can even use a protocol called netconf to dynamically provision the forwarding path into the network, and so I can bring customer circuits to life in an automated, optimized, on-demand fashion is the whole idea of this, right? So what I need you to know about NorthStar, it's an SDN controller for the WAN space that is used to discover, optimize, and provision MPLS label switch paths in a service provider or a large enterprise WAN, right? That's the big picture view of what this does, right? It has analytic capabilities. You can install, it's an optional component of NorthStar, but you can install some analytic collectors. You need at least one, but you can, in a large network, you may have multiple collectors, and it gathers data, telemetry data about interface utilization, tunnel demands, and traffic demands on your network. And based on the analysis of that data, it can dynamically re-signal label switch paths across the network. So you specify thresholds. If a particular link is over a certain percent utilization, I want the NorthStar controller to recompute the forwarding paths of the LSPs that utilize a particular interface, for example, and then re-signal alternate paths to utilize alternate forwarding paths through my network that are currently underutilized, so we can move, and fine-tune, automate the tuning and optimization of our network. So again, it's an optional component. You don't have to use this, but it's something to help you out. And remember, we talked about last week the old self-driving network, right? That based on network conditions, we can analyze network conditions, and then in this case, have the NorthStar controller tune and optimize how our network's performing without any human being needing to be involved, other than letting the NorthStar controller know what the acceptable network conditions are, right? Exciting stuff, right? Visibility, you can see everything, the nodes, the links, the tunnels. I think that might be the next screen. Here it is. It's a web-based interface. You'll open up a web browser and you'll browse to the NorthStar controller. And there's a series of tabs. There's a network info pane. It's down here on the bottom, and there's a nodes tab, a links tab, a tunnels tab, a demands tab. You could add more tabs in it. And this is all the data that the NorthStar controller has discovered, has learned about your existing network, right? And you'll get a topology map where you can see, again, all the nodes and all the links. You can click on things in this pane and view them here. So one of the things people like is just the visibility that you get from the NorthStar controller about your network, right? In a nice GUI that's easy to view and understand. Right, and then you can there's heat maps. There's here's the utilization, where you can see like the link utilization, tunnel utilization, and this is the telemetry data that can be gathered and analyzed by the NorthStar analytics component. So again, just really great real-time visibility into how your network is currently performing. is the idea with this, right? It has the ability to schedule bandwidth. You can, increase or decrease the bandwidth of an existing LSP, or schedule the provisioning, new label switch paths. So, you can say, hey, I need a new LSP between Denver and Chicago. I need it to be instantiated Friday at midnight, and then I want it torn down, Sunday at 6 a.m. in the morning, right? 6 a.m. in the morning from the Department of Redundancy department there. So, it's capable. Remember that's the whole thing here with this software-defined networking is I can dynamically, automate, orchestrate changes to my network, right? So I can schedule circuits. Since it has a big picture view of the network, my customer requires the ultimate in redundancy. They need redundant circuits between San Francisco and Denver, and they can't cross the same physical, fiber link. They can't cross the same node. Since the NorthStar controller knows all of the links and all of the nodes, it can compute, redundant label switch paths and then signal them into the network that meet the customer requirements, right? Whereas an individual node doesn't really know all that. It doesn't know that if I signal both of them this way, that somewhere down the pipe, those two, logical circuits are sharing the same physical link. It doesn't know that. And that's one of the benefits of having that centralized controller that sees everything, not just its connectivity, right? Kind of cool stuff there. Maintenance events, again, software-defined networking. If I need to remove a node from the network to do a software upgrade or perform some type of maintenance, I can tell the NorthStar controller that I'm going to take a link offline, or I'm going to take a node offline. And the NorthStar controller can analyze that and determine, okay, well, what label switch paths traverse that link or traverse that node, and dynamically re-provision them around the hardware component that I plan to take offline. And then once I do my maintenance and bring it back online, I can tell NorthStar controller the maintenance event is over, and if you would like, it can re-provision things back to the way they were, right? And so again, that's the benefit. Imagine having to do this manually, right? Having to compute, well, how do we do this? Which circuits cross that node? How do I, the NorthStar controller can do all that for you at the push of a button, right? So it's that's a big benefit, right? And then we have the NorthStar Planner, which again, here's what I need you to know about that is that the NorthStar Planner can build an offline model of your network. You'll see all the links, all the nodes, but instead of this being a view of your live production network, it's a view of the offline model. And this is a very popular feature with our customers because they can use that offline model to then do simulations. What would happen if this link went down? How would the label switch paths be affected? Would all the label switch paths be able to still function? How would they be re-signaled on the network? Would that cause any links to be oversubscribed? Would that increase delay at certain points in our network to where we're no longer meeting our customer service level agreements? And what would happen if we added a new link here, added a new node, changed a routing metric? How would that affect my network? So then I would know that if these same events, or if I made these same changes into my production network, I know ahead of time what would happen. So it's the ultimate in network simulation capabilities here, right? And I'm doing it in an offline sandbox, and so I can know before I make a change in production how production would be affected, right? And it's called the NorthStar Planner. So it uses all the information that the NorthStar controller learned about your network and makes a copy of it. And it's called a network model. I don't need you to know about this software. There was some software from Juniper Networks called IP MPLSView. All of the functionality of this product has been migrated to the NorthStar Planner. It's no longer called IP MPLSView. The same features and functionality are called NorthStar Planner. You will not get any questions on your certification exam about IP MPLSView. So I'm gonna kind of skip through this. I don't need you to know this. All of this is now called the NorthStar Planner. There's no IP MPLSView server anymore. There's no IP MPLS. All this is gone. This is a little bit of legacy information. So I don't need you for your certification exam to study IP MPLSView, right? All of this is done differently now. It's the same thing. I build a model of the network and I can view it. It's just I do this using the NorthStar controller now, and I use the NorthStar planner to view the model, right? So, this information kind of needs to be removed from the course, okay? So I'm going to kind of breeze through this, right? We build a model and we view it. But again, this is all legacy stuff, right? And it's all used for the same thing. What would happen if, right? What would happen if? So the exact same features and functionality, it's just called, what happens if this link, this node, this site, this slot, this card, what happens if this fails? Again, I do all the same things, but it's not called IP MPLSView anymore. It's called NorthStar Planner, okay? So what I need you to know about this module, SDNWAN, is that we have a software solution from Juniper Networks called the NorthStar controller, and it is used as an SDN controller that can dynamically provision MPLS label switch paths traditionally into service provider or large enterprise WANs, right? Service providers sell, MPLS services to customers, and this solution allows them to, orchestrate the instantiation of those types of circuits for customers, right? And so that's the thing I need you to know. And then it uses the Path Computation Element Protocol, or PCEP, to communicate with the forwarding plane components in your network. And that's how LSPs are discovered and provisioned, right? And then we don't need to worry about IP MPLSView. All of that functionality has been migrated to a new software called the NorthStar Planner, right? And that's it, right? So kind of an easy one there for you to study. Let's keep going. We're having so much fun. That was Module 8. Well, let's look at another solution here in Module 9. And this is we're going to talk about a software solution from Juniper Networks called Contrail Services Orchestrator, right? Contrail Services Orchestrator. So we're going to talk about what it does, what are the parts, what problems does it solve, right? And so let's get going here. Every single one of us has dealt with something called customer premises equipment, right? Every single one of you has signed up at some point in your life, at your home, your dorm, your apartment, wherever you live, right? Internet access, internet service, right? I moved into this new apartment and I need to get internet set up. So, you contact whoever the service provider is that has, that offers services in your location, and hey, I'm moving in on the 21st and I want internet access. How does that work? Well, for where I live, it traditionally means somebody needs to come to your location, bring some type of hardware. So a human being shows up in a truck with a box, and they have to come into your house, figure out where the internet connection comes into your house at, and plug the box they brought into it and program that box with the speeds and the services that you want, and then test it out and then leave. And then what's the problem with that? They have to bring their own box. It takes a long time for the technician to show up at your house. We'll be here within 8 to 10 business days, and we'll show up between 9 a.m. and 5 p.m. So you're stuck waiting around. It's just a mess, and it's hard for the service provider to find human beings that are capable of, configuring these devices and are responsible enough to actually show up and stay employed for a little while. So it's a slow, time-consuming process. If I'm an enterprise business, let's say, and I have remote locations, I have branch offices all around the world, and every time we open up a new branch office, there's a long lead time because, of the services that we require at each. Say I'm a bank, right? And I open up a new bank branch. Well, because of legal and financial compliance reasons, we have an extensive list of network requirements that we have to fulfill every time we open up a new connection to the network, right? I need to be able to get the folks and the equipment at that branch office online. I need a firewall. I need layer 7 firewalling and IDP capabilities. We need routing to connect all the branch offices together, and we move so much data. And so every time I open up a new branch, there's a chain of devices that have physical devices that, some provider in the local area of that branch needs to bring and connect and provision and monitor and maintain, and it's a slow process. And imagine the service provider having to find a human being capable of programming a WAN optimizer and a router and a firewall and a LAN and a switch, a wireless access point. They might have to send 3 or 4 techs out to each branch, and it's just going to be tough. It's going to take a while. That makes me sad. But I, as a WAN provider, an internet connectivity provider, been reading a lot about this whole cloud business and how these cloud folks are just pushing a button and automatically instantiating services, spinning up containers, spinning up virtual machines. Love what I'm hearing, and that could really change my business model. We talked last week about network function virtualization, how all these network functions like load balancing and NATing and firewall and IDP and WAN accelerator, it's always been done on appliances, right? And how over the past several years, these appliance vendors have been pressured to separate their software from the hardware appliance that it runs on and get it to run on a virtual machine or a container. And if that's the case, that could kind of change the customer premise equipment landscape, right? And that if I can get those services, all the services we saw back, a couple slides ago, all of this gaggle of appliances, if I can get all that stuff to run in a virtual machine format, then when my customer opens up a new branch, instead of shipping them a stack of boxes, I can ship them one. And it's called the Cloud Customer Premise Equipment Platform. And really all it is a standard x86 server with a couple of network ports in it. And then I can use some software to dynamically provision the virtual machines and the container-based applications that do the firewalling and the NATing and the load balancing and the IPsec and the WAN acceleration piece of it. So we're moving from a stack of boxes to one that can be automated and orchestrated, right? So I need software, right? And so there's a series of components. Let me kind of go. The first thing I need, and you need this too, when you get into your new house or your new apartment or you open up your new branch office, there's a local service provider in your area that would take and, they have a presence in that area, so there's a local telco, there's a local phone company, a local internet service provider that actually has a physical presence, right? A cable that runs into the back of your house or something. We need the universal, the customer premise equipment platform, the standard x86 device that I can ship out to that customer branch office. I need my vendors to move away from the appliance model and move to a virtual network function model. I need the ability to orchestrate the provisioning of those services. And I need something, that can dynamically spin up these virtual machines and the containers, and that's where this Contrail Service Orchestrator software comes in. This is from Juniper Networks. This Contrail Services Orchestrator is software that is capable of spinning up virtual machines and then building the overlay network that connects them together, right? So it's a complete solution, and it's designed to fit into this cloud customer premise equipment model that service providers want to move to, right? Is the idea. And so, kind of a complicated slide here, but here's the Contrail Service Orchestration software. And it includes OpenStack, which we talked about last week. That's the software that can spin up virtual machines. And it can spin up these virtual machines at the service provider's location. So, we take all the traffic from the customer, and this is where we firewall it, NAT it, and IPsec it, right? Or it can reach out to the customer premise equipment, the cloud CPE platform. And Juniper Networks has a platform capable of doing this. We have an NFX series of, platforms that, we partner with service providers with. And so as service providers sign up new customers, instead of shipping that stack of boxes, we ship an NFX platform. It's a standard x86 server that the Contrail Service Orchestrator can reach out to and spin up the virtual network machine, the virtual machines out there, whether the load balancers, the firewallers, the NAT, all that stuff. I can spin it up here or I can spin it up here, either way. And it also includes Contrail networking, so it can build the overlay network that creates the service chain. So all the customer traffic would flow through the firewall, the load balancer, the NAT appliance, whatever you're looking for. So service providers that are looking to move away from having to send Chuck and Gus and Sally in a gaggle of trucks with a gaggle of devices out to each new customer site. They want a faster way to offer these services to their customers. This is kind of the architecture they want to move to. So we send out a standard device that, and I pressure my vendors, look, we're not going to use your load balancing solution anymore unless you can get it into a virtual machine format. And we're your largest customer, right? And so, with that type of, shift in thinking, that this is the software solution that can, allow this to happen for you, right? This is the deal. It's this Contrail services, or it's software, right? And you can get it from Juniper Networks, and it's when you install the software, it's a gaggle of components, right? Because there's a lot of things that it can do. They say there's like over 100 little what they call microservices. It's a container-based application. So, a lot of the components that make up Contrail Services Orchestrator are a little bit, container-based applications. I don't know the licensing model. K-Mac, I don't know what the licensing is, right? I'm sure there's a few different models, but I just don't know, right? And I try not to make up answers. If I don't know, I kind of just say I don't know. But there should be, somebody at Juniper that can help you, like a local SE or a local account manager, and they do that stuff for a living, right? One of the uses of this, one of the use cases for this, yeah, K-Mac, it probably is on the side. I'm sorry, I'm not an expert on the licensing. It's software-defined WAN services, right? Out at that customer site on that NFX platform, I could spin up, for example, a virtual MX, right? And we can start building and provisioning, layer 2, layer 3 VPN services that connect all the customer branch offices together, right? That's kind of a cool service I can sell to my customers. I can spin up a virtual SRX right out there. And, what do I get out of that? My heavens. I get a, layer 7 application layer, firewall, IDP, intelligence, natting and firewalling and, oh man, I can't think of all the stuff, IP second and routing. And so, it allows me to offer, just sell these services, right? Anybody that has a business is always looking for more things they can sell to their customers. It gives them a differentiator, between their competition, right? And if I can do this, my competition may be selling these same things, but I can instantiate this for you with the push of a button and have this service running for you in a matter of minutes. I overnight you an NFX platform, and you take that cable that runs out from behind, that shelf in your wiring closet, plug it in and turn it on, right? And I'll have that up and running for you in a matter of minutes. So it's a competitive differentiator for me. And so there's a lot of different services that this model, this cloud customer premise equipment and Contrail service orchestration components can allow me to bring to market, right? Just use your imagination, right? The CSO, if I end up, I'm a huge service provider, a nationwide service, international service provider. Maybe I have an installation of CSO on the East Coast, an installation of CSO on the West Coast to manage the different, data centers and customer service sites that we operate. And I'm growing around the world. And so there's kind of a hierarchical installation that's supported, so I can have a central installation of CSO that can manage all of the distributed regional installations of Contrail Services Orchestrator, right? So it's highly scalable. You can manage, this solution, globally if you need to, right? Look, I don't expect this is. Ooh, look at this slide, right? When I install the Contrail Services Orchestration software, we talked about. There's over 100 individual kind of components that are part of this package. So there's a lot of capabilities, in this solution. They just kind of organized them here based on kind of their function, right? And some of them, there's some installs on Linux, and so there's some Linux components that are required to be installed in the base operating system. And you know, these aren't Juniper developed. This is just part of the Linux base operating system that CSO is installed on top of. And then here's all in the kind of the lighter blue rectangle here are all the components that, you know, CSO brings to bear when you install it. And each, you know, these components perform different functions. Right. And, you know, one of the couple different models, you know, I guess service providers will operate this in a couple of different ways, and kind of depending on the customer and the customer requirements. And so, you know, this whole CSO, it allows me to do orchestration, service chaining. We talked about that last week, where I can spin up a virtual machine, like a virtual firewall, a virtual load balancer, a virtual WAN accelerator, right? Where do you spin these up at? Do you spin them up at the service provider location? So when we sign up a new customer, I just ship them just a basic connectivity device, you know, a wireless access point to get them on the network, and an Ethernet port that connects them back to and all the traffic from the customer comes back to the service provider. And this is where we firewall it and NAT it, firewall it and NAT it and all that kind of stuff. Or maybe for my my larger customers, right, with more stringent network requirements, this is where I send the NFX out to them, you know, a more complete device where I can, you know, use Contrail Service Orchestrator to spin up these virtual network functions at the customer premise. And so we NAT it, we firewall it, we IPsec it before it even gets to the service provider location. So I imagine service providers will offer both solutions. It just kind of depends on what the customer requires, how much they're willing to pay, and what their legal and compliance requirements are, right? So, but Contrail, you know, the CSO can manage it in either model, right? And so here's the kind of the workflow. If I want to offer these services as a service, I need a presence at the customer location, right? And again, you know from your experience, there are certain providers at your location, right, where I can't use provider X. They don't have a point of presence in my neighborhood, in my, you know, city, whatever, right? And then you'll go into CSO and you'll kind of do some modeling where, you know, here's the services we offer for large customers, medium customers, small customers. I don't know. Then, you know, you create tenants. So when we sign up a new customer, you know, here's customer X. I define their sites. You know, they let me know where they want service at. I could ship them the NFX, for example, platform. When they get it, they connect the wire to it, plug it in, turn it on. It calls back to the service provider. Once it does that, the service provider can manage it now, and then it can start deploying the virtual machines or the container-based applications that the customer needs for the services that they require. So, you know, there's a whole kind of workflow here that you, as a service provider, will step through if you want to bring, you know, this type of service to market. All right. It's a web-based interface. There's a kind of a designer portal where you can kind of come in and say, okay, I want to offer, you know, firewalling services. So what types of virtual machines can offer these services to my customers? Where are the images stored? You know, there's a little bit of dirt work. There's a little bit of setup you have to do for your service offerings for your customers. There's an administrator portal where you, as the CSO administrator, can view the services that are offered to your customers. How are they performing? There's a customer portal where the customer can log into CSO and view their services, or this is a service provider meeting my service level requirements, and so you can see your piece of the world inside of CSO. You know, utilization, you know, complete visualization of a particular service offering for a particular customer. All that's available here inside of CSO, right? And so we reached the end of this one. So what we talked about is how things are currently done, how customer premise equipment has been managed traditionally. And we talked about some of the pain points of that: a stack of boxes, you know, slow spin up of services, and all that, and how we're moving to more of a cloud model for customer premise equipment, a standard x86 platform that can be quickly deployed at a customer site, that doesn't require a lot of provisioning. We can automate and orchestrate the instantiation of services on that platform, and bring services to market in a much quicker fashion, right? And that's going to give me a durable competitive advantage that will bring me more customers and get me more money, right? So I get my bonus this quarter, okay? And the software and the solution from Juniper Networks is called Contrail Services Orchestrator, along with our NFX platform. So we have kind of a hardware and a software solution that allows service providers to offer this type of solution, right? The different portals, there's just there's just when you open up a web browser, there's a portal where you can design the services for your customers. Here's the the firewall services, the NAT services, the load balancing services, right? And then there's a portal where you can view all the customers and how they're performing, and there's a portal for the customer themselves where they can see their particular slice, their services that they're purchasing from you and how they're performing. And this is a view of that customer portal, right? All of the branches, how they're connected, utilization, performance levels, delay, stuff like that, right? Okay, so that's it for that module. Hey, you're welcome. You're welcome. Let me get our last one. I've got some good news, everybody. This is our last module, right? And this is going to deal with security. And so we're going to talk in this module about something called software-defined secure networking, right? We want to use these cloud concepts, the automated, orchestrated, instantiation of services, and apply those to the security world. And that's what this module is about. So we're going to talk about software-defined secure networks, right? And how what solutions does Juniper Network have to allow this to all be possible? So we start talking about, security in networks, right? And every one of us has done some type of security in a network because every one of you has some type of computing device, a tablet or a laptop or, regular desktop PC, and you probably got some kind or have at some point in your life some type of antivirus software on there, right? And so there's, way down deep in your network, every little device has some type of antivirus software that's on there, and it has a pattern database of known bad stuff, and it has a scan engine, and it can scan your file system looking for that known bad stuff. It's automatically updated every night. We get a new pattern file with new bad stuff and all that kind of cool thing. That's kind of neat, right? Signature-based security. Kind of cool. Also, in the past, networks were more rigid in their structure, okay? You didn't have people walking around with tablets and laptops and moving to different places and taking their computers home and bringing them back to work. Networks are more rigid in their structure that, and that allowed me to kind of assume some things, right or wrong, that all of the machines in my network, since I had such control over them, Fred couldn't take this machine home and do horrible things with it. Neither could Sally. That I could basically assume that inside of my network is pretty safe. You couldn't bring a tablet from home and connect into the network, and who knows what that tablet has on it, software-wise, good and bad. And all the bad stuff was outside. This is where the bad network was. The internet, the public networks were my, business part. And so I could really secure my perimeter of my network with something like a firewall. And as long as the traffic flowed in this direction, I could protect myself, right? But that doesn't work anymore because that probably never was truly a good idea. That outside bad, inside good was kind of a bad assumption. And so now with networks being so mobile, that these are laptops, these are my sales folks, and they're on the road 90% of the time. They come back and upload their, and I don't know what condition these machines are on, right? So the idea of outside bad, inside good just really isn't a viable model anymore, right? I have to kind of assume that threats can propagate anywhere in my network, and Sally bringing in a machine or Fred bringing in a machine that's infected can start infecting other devices in my network, and the firewall will never see that. I could have some super duper awesome firewall that can see any kind of threat in the world, but if the traffic does not reach the firewall, then it's invisible to me, right? And so threats can propagate in a lateral fashion on my network, and I have absolutely zero visibility. And so I just can't rely on a strong border to protect myself, right? And so outside bad, inside good is muy peligroso, very dangerous, right? Can't live like that. That doesn't work. So we're going to look at some concepts that allow me to dynamically deploy security settings deep down into my network, and we're going to get into what's called software-defined secure networking. One of the things that people seem to really be interested in the past few years is leveraging external threat intelligence, right? We're going to start talking about device view of the network and network-wide view and excuse me, global view of threats, right? Man, excuse me. My firewall is pretty smart. It has, a lot of feature capabilities that help me protect my network. But there are things out in the world that my firewall has not seen, and that I'm not, have not seen on my network. And if I have not seen this threat, how do I protect my network from it? And so what people have been doing a lot lately is leveraging external intelligence. There are vendors out there, one of them being Juniper Networks, who maintain in the cloud large databases of known threats, threat behavior, malware behavior, and they sell this knowledge to customers. And so this firewall can leverage a huge knowledge base out there that it may not be capable of using on its own. And based on this big bag of knowledge, it can dynamically provision things like security policies to protect your networks against threats that it hasn't even seen yet, right? And so it allows you to be more proactive, right? You can do things like as traffic comes into your network, email or web downloads, it can pause that data from entering your network and forward it to external services, to where that data can be analyzed in a more complex and more complete fashion than the firewall is capable of, and make decisions about yes or no, is that allowed to enter my network? So I'm able to increase the capabilities of my security platforms by leveraging external services, right, is the idea. And so, the world has changed, and all I hear about anymore is artificial intelligence and machine learning, right? And using those tools to analyze big data and based on the results of that analysis to automate a solution, right? Automate a function in my network. So, we're kind of looking at this, right? I think we break this down on a slide by slide basis here. Big data, right? My firewall has certain security capabilities, certain things it has seen, certain actions it's able to perform for me. But again, we talked about earlier that my firewall is only capable of handling things that it has seen, right? Remember Fred and Sally bringing those laptops back, and I'm getting lateral spread of vulnerabilities across my network. And up until this point, that traffic never has crossed my firewall, right? And then, there's these large providers of these cloud-based security services like Juniper Networks that gather information about threats on a global basis, a huge, big picture view of threats that are out there that your network or your firewall hasn't seen. And so because it hasn't seen these threats, it is not aware and capable of protecting your network from them, right? And so what we do with this big gaggle of data about all these threats in the world is we perform, machine learning against that. Which all that means is somebody wrote some really cool software that can analyze a big old pile of data looking for things that it's programmed to look for. And if you know how do you know, think about this, right? How do you know when you're sick? Right? You know when you're getting sick because you feel different than when you're feeling well. Hey, man, I'm getting a headache. My throat's starting to get sore. My body's aching a little bit. I don't feel like this normally, right? And so we can use machine learning, right? I know what an application does when it's acting normally. I also, based on that analysis and that learning, that knowledge, I can think that, wow, that application is not acting normal anymore. I know how a network looks and when it's acting normally and it's not acting normally now. And so that is some type of threat going on. And that's what this machine learning can do. It can analyze a big pool of data in an automated, rapid fashion, quicker than you would notice things. And I learned from that, right? And that's the whole idea of this machine learning piece. So we take a big picture, view of threats, and we analyze that. And so I have some information that this little device doesn't know about or is not capable of knowing about, but it can leverage that information and implement security settings that can help protect your network against threats that it just hasn't even seen. So doesn't that make you Jimmy and Jane proactive, right? And then the whole automation piece, right? Oh my heavens, yep, there's a threat out there. We use this automated learning and artificial intelligence. We can see it. Now we need to protect ourselves. So how is it done today? Well, all hands on deck. Get everybody into the network operations center and let's start programming security settings in all of our devices. That's quick, isn't it? That's scalable. That's consistent. So we've tried to automate this as much as we can. We have some security templates and we've got some scripts. So we need less than Freds and Sallys on the deck to make this happen. But it's still a lot of things that we have to manage. Whereas look at our good friend automation, right? In that with just maybe one Fred or not even needing a Fred or a Sally, I can, based on the let me think of how to say this, based on network conditions, I can automate the deployment of security settings across all of my platforms deep into my network. So I'm protected against threats that I may not even have seen on my network yet, right? And so that's kind of the idea here, folks. And it's called software-defined secure networking, right? I have a centralized a centralized component that can automate the deployment of security settings deep into the components of my network. So I can stop threads at the front, the border of my network, and also stop lateral spread of security threats. Because again, I'm able to automate the deployment of security settings deep down into the components of my network. And so again, I can deploy security everywhere, not just at the firewall at the edge of my network, right? Because I'm still going to be blind to certain types of threats, but to every networking component in my network, right? So I can stop threads before they spread. So we want to, we want to move from the perimeter hardware manual, slow, to the automated, orchestrated, beautiful, shiny new way of deploying security settings, right? Way down deep in my network using external, threats and automate the deployment of security settings using open, standardized ways of doing things. It's a brand new, shiny world out there, folks. And so the components from Juniper Networks, we're going to talk about 3 of them. We're going to talk about some software called Policy Enforcer, Security Director, and then Sky ATP, right over these next, few screens. And so here we are. Instead of having security just at the edge of my network, with software-defined secure networks, I can deploy security settings on switches and firewalls and the additional components that make up my network, right? So I can treat my entire network as a security device, right? So when Fred or Sally plug into that switch port in their cube over there, right, I can analyze the behavior of their connected device, and based on that analysis, if I determine there is a threat that Fred is propagating throughout my network, I can literally, using the software-defined secure network concept, deploy an access control list down to that switch to drop that switch port on a remediation VLAN or disable a port, right? And that'll make Fred call me. And so I'll have him bring his laptop over to the security operations department. We'll figure out what's going on here, right? Without having to wait for that threat to propagate throughout my entire network and then generate traffic across my firewall before I realize what's going on. So it's a bigger picture view of security in my network, and so here is a little bit of the architecture, right? And so we have an application called Juno Space, and it's a management platform that allows you to install additional management software on there, and one of them is software called Policy Enforcer. And there's another component called Security Director too. What's the next slide look like? Oh, that's no fun. Okay, let me go back. Just trying to make sure I can tell this story correctly. And so what Policy Enforcer can do is it can communicate with external, cloud-based third-party feeds. Like it can learn about command and control software. Fred's machine's been compromised by a cyber bandit, and it's calling back out to some external system, and that external system can, execute commands on this platform that scan my network and look for, valuable things. And that's bad, right? And there's certain IP address ranges out there that, come from, bad places. There's threats. And the Policy Enforcer can learn about that, and once those things are discovered, the Policy Enforcer can deploy security settings to my firewall, to my switches that make up my network, right? Deploy access control lists, disable a port, put a port on a particular VLAN, right? And that's kind of the idea, and it can do it in an automated, orchestrated fashion. I don't have to deploy security settings. It can deploy security settings, is the idea. And so when you think the way it's done now, right? There's a threat on our network. I came in this morning, every morning. First thing I do is I go into our log analyzer and I look for threats, and it looks like there's something here. So what do? I open up a ticket, right? And then, okay, we've got a 24-hour service level agreement on that ticket, and then we've got to have a meeting. Is this a threat? Is it real? Is it a false positive? What do we do? What's going on? No, it is. And then, okay, how do we solve this, right? Well, we've got to go in and create a new access control list on that router, or we've got to set up a new rule on the firewall. We've got to do, and then finally we can remediate a threat. And the whole time that threat is propagating through my network, in microseconds while we're having a meeting. So, that's kind of how things are done, though, right? You can't move the ship too fast because it might be a false positive, and congratulations, you just performed a denial of service on yourself, and that ruffles feathers, doesn't it? So what we like to do is be able to automate the remediation of types of threats, and this is where our good friend Policy Enforcer comes into play. We already talked about it's capable of deploying security settings automatically to platforms in your network, and what it can do is it can, let me think of how to say this, it can leverage external knowledge. Juniper Networks maintains a cloud-based threat intelligence service called Sky ATP, Sky Advanced Threat Protection is how you spell Sky ATP, right? And it's a gaggle of information about threats that have been seen on a global scale, right? Things that you haven't seen yet, right? Threats that have not reached your little corner of the world, but that do exist out there, right? And it also provides things like sandboxing, like I was talking about when files come into your network, email attachments. It can those attachments can be sent to Sky ATP, and it can analyze them in a more intense, detailed fashion than your firewall is capable of, right? Or your local antivirus solution is capable of analyzing them, and send information back about, hey, here's a bad file, hey, here's a threat. And then based on that, the SDN, the Policy Enforcer it can take action. Hey, let's block that. Don't allow that in. Let's set an access control list here. Let's deactivate this port. Let's put this port on VLAN X, right? So Fred can't propagate a threat on the network. And so based on external, big picture global knowledge, the policy enforcer can learn things that your network doesn't know and be proactive in protecting you from it. The bad stuff that exists in the world, right? So to set this up, the components, I mentioned a couple slides back, we have this management software called Juno Space, and it's you download this. You can get it in a virtual machine format, and then there's a couple of applications that install on top of that. There's a lot actually, but the two we're focusing on are Security Director. Oops, excuse me. The Security Director has been around for a long time, really. This is when you have a lot of SRX firewalls on your network, be they virtual SRX or physical SRX. Security Director has been the management application that's used to, for example, to create security policies that you can deploy to all of your firewalls. Right? I don't want to manage all 100 of these SRXs manually. The Security Director can do that for you. Right? So this is a scalable automated management solution to manage a bunch of firewalls. And then the policy enforcer component can also communicate with these external threat services like SkyATP, and it can deploy security settings to your switches and also wireless access points that you may have on your network, right? And then the SRXs can register with the SkyATP service, and again, as I was saying, as data comes in, email attachments, or your users are downloading files using HTTP, we can quarantine those files for a minute, send them to SkyATP so they can be executed and analyzed, and then we can get a yay or nay to let this pass or not, right? And again, it can manage third-party switches, wireless access points. That's what this solution, these software components allow you to do. Manage your SRXs, manage your wireless access point, manage your switches, and so we could use this solution to better protect your network and all of the components. And again, from the Department of Redundancy Department, this policy enforcer application can leverage external threat intelligence information, and based on the analysis of the data that's being seen in your network, or the threats that are being seen in your network, it can communicate with the Security Director component to deploy security settings to your SRX firewalls. And also settings to your Juniper switches, or external third-party switches or wireless access points on your network. So again, it's a way to learn about threats that maybe you have not seen yet, and to automate the deployment of security settings to protect you from these unseen, unknown threats, right? So you're being, proactive security administrator, right? And again, the Security Director component is what deploys security settings to your SRX platforms, right? Policy enforcer deploys the settings to your switches and your access points out there that aren't SRX firewalls. So these two components kind of work in tandem to deploy security settings down throughout your network. And then the SkyAT component, this is the Juniper cloud-based threat intelligence solution, right? That command and control feeds, GeoIP, sandboxing of threats, so we can analyze data before it's allowed to enter your network. And so these are the different components that make up software-defined secure networking. And switches are important, aren't they? So are wireless access points. This is these are your users' first contact with the network. This is how they plug in, right? This is how your servers access the network, your clients access the network. And so this is a primary enforcement point. And again, this is where policy enforcer can deploy security settings down, and again set a port, for example, a port on a switch to remediation VLAN, or disable a port, right? So Fred can't get on the network and spread those threats to everybody else in the accounting department. And now these external row actors have my entire accounting department under their command and control, and that makes me look bad on the news, right? And so that's kind of the solution. And it supports multiple vendors, right? You're not tied into a Juniper solution. Of course, all of your network components will be Juniper components, right? But just in case somebody sneaks in some, non-Juniper equipment, it's completely capable. It's a standards-based solution. So as long as these components support something like Radius, then I can deploy using Radius attributes, put this on this VLAN, disable this port, right? I can dynamically deploy using Radius attributes security settings out to these third-party components, right? And so in this module, the main focus was software-defined secure network. So, right, anytime we're talking software-defined, we're talking about a centralized control solution, right? That can, in this case, leverage external knowledge, big picture global knowledge that can allow us to learn about threats that we may not have seen yet, allow us to leverage external security features and functionality that we may not be capable of. And then based on that external big picture knowledge, it gives us the ability to automate, orchestrate the deployment of security settings deep down into my network. And I don't have to rely on outside bad, everything inside good model anymore, the trusted security model. So, and Juniper's name for that model is software-defined secure networks, right? And so some good news for you. That's all I've really got. That's the last, kind of 3 modules of your Juniper Cloud Fundamentals course. Now, I want you to be successful on your JNCIA Cloud exam. So again, my best recommendation for you would be to go consume that content inside of Junos Genius, go through those modules, have somebody else explain, these concepts to you using different examples, different use cases. And so hopefully, you'll deepen your understanding of them. And that's what you're going to need to be successful on the JNCI Cloud exam. Again, I don't think it's the world's hardest certification for you to obtain, but the best way to be successful is to consume the material. So please take my advice and do that. And then, as Lawrence said, you get 3 cracks, 3 attempts at that JNCIA Cloud Practice exam, and you need to get a 70 or better score on that to qualify for the voucher. So make sure you consume the material before you start burning up your attempts at that practice exam, right? Because I want everybody to get a voucher, and then I want you to be successful with the voucher. So that's my best recommendation is consume the materials. I want to thank you for taking the time out of your busy life to learn about Juniper's cloud solutions and technologies and platforms, and just say really thank you very much, right? And good luck. Let me see if I've got any questions. Cyfort versus, are they the same thing? Yeah, they are. Cyfort, KMAC has, we call it JATP, Juniper Advanced Threat Protection, that came from Cyfort, and it's designed to be more of an on-premise version of SkyATP. Really, it can perform many of the same functions that our cloud-based service does, but if a customer wants that same functionality in a local version, on-premise version, they would look at the JATP appliance, okay? Or it comes in a virtual machine format as well. But yep, that's it, KMAC. You've got it, okay? So hey, everybody, again, I just want to say thank you very much, right? And keep looking for new opportunities from Juniper Networks, new learning opportunities. Get your JNCIA Cloud and then keep going. Get your specialist, get your professional, branch off into other technologies. The more you know, the more valuable you're going to be to your current or future organization. So just thank you very much again, and good luck. Lawrence, I'm going to turn it back over to you.
Alrighty, sounds good. Thank you, Gordon. Thanks, everyone, for attending. I did just want to kind of mention, in the spirit of what Gordon was just saying, kind of branching out and trying different things. Most of you are probably aware we have the JNCIA Cloud, but there are also other offerings available through the Open Learning Program. You should take a look at JNCIA DevOps. It's a fairly new one we just added within the past couple of months. And we also have our design certification. That one is now going self-study, actually, as of today. You're probably the first group to hear it. But that is going self-study, which means you no longer have to sign up for a session to access those materials. You can literally just go into Junos Genius, and right next to your JNCI Cloud materials, you'll see a square or a tile or a link that says JNCDA. If it's not there, it will be there by the end of the day because that's a change we're making to the program based on some feedback. So, get a design certification, see how things, come together from a network development and design perspective. Of course, we also have JNCIA Junos is available. We periodically hold sessions for open learning for that. So a lot of great opportunities around open learning. Do take advantage of them, where you can. And good luck with this exam. And I just see from Enda, looks like JNCD is there. All right, excellent, good. All the levers and switches were pulled correctly. Go get yourself certified. Just remember, for cloud and for design, both of these, because they're publicly available inside of Junos Genius, there's no timeline on when you have to take those, right? You can consume the material at your pace. If you want to do it in 3 weeks or 3 months, it's your choice. You have that time. It's just once you earn that certification voucher, they're typically good for a period of about 90 days. So really, that's it. Good luck with your exam. We'll hope to see you in a future open learning session, or perhaps via the self-study route. And good luck on all your future exams. Take care.